Hi everyone, it's Mr. Hamilton here. Today we're going to talk about solving linear systems by graphing. If you're in math when this video is first recorded, we're delaying the test because we have yet another freezing rain day today, and so we're going to get into the new unit and do the test the next school day. A linear system is represented by two or more linear relations. That's your first blank on this handout. Two or more linear relations. You could have two straight lines, but you could have 3, 4, 5. It could be as many as you want. And so what those linear relations are going to do is they're going to form a point of intersection if it's just two lines. And we call that the solution. Now, if you have 3 or more lines, we could form more than one point of intersection, right? If we have 2 lines, there's one point of intersection. If we have a third line, it could form the same point of intersection, but it could also form 2 other points of intersection. We're actually going to do some things with that later in our unit, where we consider if I have those 3 points of intersection, what type of triangle is that it forms? So that's something coming later that you can start thinking about. The POI solution, the point of intersection solution, will make each equation equal when the x and y values are substituted into each equation. The point of intersection solution will make each equation equal when the x and y values, a certain point, x, y, are both substituted into each of the two equations. You can check to see if your solution is correct by substituting the solution into the left side and the right side. And we've done that with checking to see if equations, if we've solved an equation correctly in the past. So how do we actually figure out this point of intersection or these points of intersection? Well, there's 3 ways to do that. One way we can do that is by graphing. That's the first way, and that's what we're going to look at today. The second way we do that is by substitution. And we'll look at that in a subsequent lesson. And then the third way, which we'll also look at in a subsequent lesson, is elimination. So we're going to graph it, we're going to substitute it, or we're going to eliminate it. And we're going to find that sometimes one method may be easier than others. In general, substitution is probably going to be the go-to method that many of you use coming out of this unit, but we want to get a visual for what that looks like by graphing today. And then we want to use elimination because that's a method that we'll learn later, like I said, that's going to be really helpful in certain situations when equations are laid out a certain way. So how do we do this by graphing? Well, the first thing we do is we write each equation out in y equals mx plus b form. We do know that we could graph it using the x and y intercepts as well. That would work well. But in general, we put it in the y equals mx plus b form. Once we do that, we prepare our Cartesian grid so that all points will fit. So we have to choose a scale. We have to label the axes. And we should put some titles on it if it's a word problem. Number 3, graph each line using the y-intercept and slope. The b value, the y-intercept, is what we start with, and then we apply the slope to that y-intercept. We rise and run from that b value. And finally, 4, we identify the point of intersection as the solution. So here is our first example. It says solve the following linear equation or linear system graphically. Check your answer. So you notice that neither one of these is in the y equals mx plus b form. So what we're going to do is we're going to do a little bit of algebra to make it so that it is. So what I want to do here is I'm going to subtract x from the left side, and whatever I do to one side, I have to do the other. So this becomes y equals negative x minus 7. We write the negative x first because then it's in the y equals mx plus b form. Now you might think, well, what's the slope? Well, the slope in that case is 1. Well, that's or negative 1, I'm sorry. That's the rise. What's the run? Well, any whole number, it's like it's over 1. So there, that makes it a little more clear what everything is now. So this first equation, we have a y-intercept of negative 7. That's what we're going to start with. And we have a slope of negative 1 over 1. A rise of negative 1, a run of 1. Let's go ahead and graph that, and then we'll graph the other one. So what I'm going to do is I'm going to start with my y-intercept, and it seems to me that I could go up by a scale of 1, and it may actually be a good idea to confirm that with the other equation before I set that scale. So let's continue doing that first. Let's add 3x to both sides. And then if it's just a 5, it means it's a plus 5. And so we could say that y equals, the 3x cancels off the left, 3x plus 5. And just like we noted before, a whole number is like it's over 1. So that means that for this equation, the y-intercept is 5, and the slope is 3 over 1. So I'm going to go ahead and I'm going to set up my scale so that I'm going every square is 1. I don't need to label every square, so I'm going to label every 2 squares just so that I don't clog the graph too much. But I do need to make an axis. I do need to scale and label my axes like that. And I also should label them with an x and a y. I'm also going to label the negatives. Make sure that that's going up by an equal amount the whole time. And there we go. That's ready to graph now. So I'm going to start with the first equation where the y-intercept was -7, right there. And then my slope is -1 over 1. So it rises -1, goes down 1, then goes 1 to the right. We're always going to the right. Down 1, 1 to the right. Down 1, 1 to the right. And we're going to continue that. We can continue that pattern backwards a little bit. And then what we're going to do is we're going to get our ruler. And we're going to draw a nice straight line as best we can. This is a little tricky with the computer here. As best we can through those points. I'm just going to have to drag that over a little bit here on the computer. Looks just like that. Okay, so that's the graph of that first equation. So I'm going to label it with the original equation, x plus y equals -7. Now you want to make sure you expand it out quite a ways because we don't know yet where the y-intercept is going to be. And so if you only expanded it to here, let's say, then you might not find the y-intercept. So try to fill up your grid with the whole line. So now the other line is the y-intercept is 5 and the slope is 3. So I rise 3, I go over to the right 1. Rise 3, go over to the right 1. And then I continue that pattern backwards. And you can see a clear point of intersection right there, just as I put those points out. We'll grab our ruler again, draw the lines through those points, or draw the line through those points. I'm just going to have to drag that over again on my computer. And I'm going to label that with y minus 3x equals 5. And so the point of intersection, which is the solution, we can see is -3, -4. So be sure to label that on your graph as well. So we think we've solved it. Now we want to check our solution. So what we're going to do is we're going to go to the equation 1. This is equation 1 and this is equation 2. So for equation 1, we're going to substitute the x and y values. So we're going to sub -3 and -4 into the equations, both 1 and 2. But what we're going to do is we're going to get in the habit of doing that by checking the left side and the right side separately, because if we're wrong and we've said it's equal the whole way by not doing it separately, then we've made a statement that's not technically true. We're probably right, but we always check like this just to be sure. So what I do is I say the left side of that first equation is x plus y. I'm not doing anything with the -7. That's the right side. So the right side is -7. And we draw a line between those just to say, okay, we're separating those two sides of the equation, and at the end we'll check if they're equal. So x is -3. We're going to substitute y is -4. -3 plus -4 is -3 minus 4, which some of you can do in your head. That's great. We get -7, and we say, therefore, the left side is equal to the right side. So what that tells us is that that point satisfies that equation. It doesn't tell us yet if it did the other equation, so you can't conclude that you're correct yet. So we move to number 2, the second equation. Y minus 3x is the left side, and the right side is 5. Again, we draw the line between those. So y is -4 minus 3 times -3. So -4, negative times a negative is plus, is addition. 2 negatives make a positive. And so we have it being +5. Well, that's the same as the other side. So therefore, the left side is equal to the right side. And we can conclude, therefore, the POI we've checked and now know it's correct is -3, -4. Now, in general, you don't have to check. But if you're ever doing a test or something and you have extra time, this is the way you should make sure that everything's correct. And occasionally we will ask you to do that. So make sure you know how to check it, but it's an extra step that just tells you, I'm absolutely sure that I did that correctly. So it's not usually required. All right, let's look at another example here now with a word problem. Fitness Club CanFit charges a $150 initial fee to join the club and a $20 a month fee. Fitness R Us charges an initial fee of $100 and $30 per month. Now you might say this seems ridiculous, but this is actually kind of the model that many clubs use for you to join. And so what we're going to do is we're going to try to come up with an equation for each of these clubs. And so what I'm going to do is I'm going to underline some keywords. $150 initial fee, $20 per month. That's Club CanFit. And then Fitness R Us has an initial fee of $100 and $30 per month. So the thing that is consistent every month, this is the slope. And the thing that is the initial fee, that is the y-intercept. That's the way we approach these. And so what we'll be able to do is graph each of these and find where the point of intersection is. So if it says to find an equation that represents the cost at CanFit, what we're going to do is we're going to let x be something, and we're going to let y be something. And I want to encourage you to pause the video here and see if you can identify what those variables should be. Actually, go pause the video and try to identify what those variables are in words. This is a very important step that a lot of people overlook. And so what you should have is that x is the number of months, or you could say let x represent the number of months, and let y represent or be the total cost. So for CanFit, which is that first club, they had an initial fee of $150 and a $20 per month fee. So the equation there is the cost is equal to $20 per month, so $20 times x is the number of months, plus the $150 initial fee. The same variables would be defined for the other fitness club, Fitness R Us, and that would have the cost is equal to $30 times the number of months, plus $100. So those are our two equations that we have to graph. So it says determine the point of intersection for the two equations. So what you want to do right now, I want you again to pause the video. I want you to graph this, and in this case we don't need 4 quadrants because we're talking about positive money. And try to think up a scale that would be useful for these. What I'll do is the next screen I show, I'll show you my scale so you can check to see if you've got a scale that's similar to that. And then we'll go ahead and graph. So here's what I did to figure out the scale. I just picked a number that I thought they might be crossing by, and I chose 10 months, and I subbed that into each equation. So for CanFit, 20 times 10 plus 150, and I got 350. For the other Fitness R Us, I did 30 times 10 plus 100, and I got 400. Now I noticed that CanFit was more expensive to start, but after 10 months, it's $350 and it's $50 cheaper. So that means that after 10 months, they've well crossed each other. And so that I'm safe with a scale that's less than 10 months, a little bit less than 10 months, and I chose 7.5 months, figuring they'd cross by then. And I then took that number 350 and I made that kind of the top of my scale, and I went up every 2 squares is 50. Now you might have chosen a slightly different scale here, but this is one of the ways you do that. You kind of look at them and say, where would it approximately be a realistic number to try? You might have tried 5 months, you might have tried 10 months. You wouldn't want to go too much higher than that, because what you can see is that one of them is starting $50 more expensive than the other, but yet it's $10 cheaper every month. So you might intuitively think, well, if it's $10 cheaper every month and I pay $50 more up front, then it should be the same after 5 months. And then if you think that, then that allows you also to set your scale. It won't always be that clear and intuitive, and if that wasn't clear and intuitive to you, that's okay. You can always pick a number that's somewhere around 5 or 10 and just test it out and see, oh, are the values crossed at that point? So I'm going to finish graphing this, and then we'll check to see if it's the same. Go ahead, pause the video, and then I'll show you a solution. So I'm limited to 15 minutes for this video, so I want you to notice a couple of quick things. I want you to notice that I've labeled my axes. I found my point of intersection to be 5, 250. And that means that after 5 months, each is going to cost $250. And I've checked that over there at the left. Pause the video.